Hello again, everyone. I'm very much hoping this is the last time for a very long time that I have to speak to you through a screen. My apologies again for not being there to go through this with you in class. We had two packets that were given out last time. One of them was the degrees, the radians, and then we got into the unit circle, doing questions like what you see on my screen now, 4 through 9, evaluating for points or evaluating for angles that are in the unit circle. You can use the points on the unit circle like you may have done for the actual homework kind of problems where it's like, all right, find what that angle or that point is at 5 pi over 4. Use your ideas of how you'd go on the unit circle to find it. I wanted to go over a few different types of questions. We're not going to finish all of these packets. You can go through the rest of the problems in, it's going to be the exact values packet that you have a lot of practice problems in. I do want to go over the remaining 3 questions in this first packet, the degrees, radians, unit circle one, just to give you an idea of what these problems are, because I will be giving you a Delta Math assignment at the second half of this video that has problems like these. I just want you to understand what they mean. For questions 10 and 11, find the values of the 6 trigonometric functions for angle theta in standard position where the given point lies on the terminal ray of the angle. What the heck does that mean? Every single angle that we draw in the coordinate plane, when we're doing anything with trigonometry, when we're doing anything with degrees, radians, whatever, we start with one ray of that angle at 0 degrees on the positive x-axis. And then, depending on how many degrees we're going to go, we may spin that other side of the angle all the way around, depends on where it is that I have to go. This one that I'm spinning right now is called the terminal ray of the angle. It's where it ends. That's why we call them coterminal angles when they end in the same spot. And this question says, I want to know the values of the 6 trig functions for this angle, which happens to pass through the point -9, 12 at some point in its travels. So that means whatever this angle is, however many degrees it is, that's what I want to find, sine, cosine, tangent, etc. And I do want exact values for those, though. I don't want to try to estimate what that angle is. I don't need to do inverse trig here. What I need to do is come up with my 6 trig functions by doing the same thing that we did to come up with those points in the unit circle in the first place. And that's build a triangle. That's say I'm going to make myself this right triangle in the coordinate plane. I'm going to have a reference angle, theta, that allows me to compare the sides of this angle, that allows me to compare the values for sine, cosine, tangent of this angle, which is here, by only focusing on the acute reference angle in this triangle. All that means is if you're given a coordinate point, congratulations, you're told how far left and right you have to go, you're told how far up and down you have to go, and then it's up to you to just complete that triangle. If you can complete that triangle, congratulations. You have the 3 sides of your triangle, label them opposite, adjacent, hypotenuse, and do what you have to do from there. Many of these cases, you'll have something that's nice, and a 9, 12, 15 triangle is actually a Pythagorean triple. It's a 3, 4, 5, but make it 3 times bigger. In some cases, like here, yeah, you will have to do Pythagorean theorem and get a radical perhaps for that 3rd side, but whatever. At the end of the day, you're then asked to do basic SOHCAHTOA stuff. Go ahead and say, what color have I not used yet? Let's go light blue. And say, here's my opposite side, here's my adjacent side, here's my hypotenuse, and just go ahead and label all 6 of my functions. The one thing that you do have to concern yourself with is which quadrant you are in. This point, -9, 12, as soon as you see the coordinates, you know this is something in Q2. And as soon as you know that you're in the 2nd quadrant, you know which functions are going to have to be positive, and then everything else would have to be negative. So the quadrant you're in is only going to impact plus and minus signs. It's not going to impact the actual SOHCAHTOA ratios. Sine is still going to be 12 over 15, which reduces to 4/5. Because you're in the 2nd quadrant, sine would be positive. So sine of theta is 4/5. Cosine of theta says I have my adjacent side of 9, I have my hypotenuse of 15. That would be 9 over 15 or 3/5. But because I'm in the 2nd quadrant, I have to make sure that that answer is negative. So that's all this question is asking you to do. When you see this, where is your point on the terminal ray of the angle, please don't freak out. It's just saying, hey, that's where you're going to draw the triangle. Either use a Pythagorean triple, do Pythagorean theorem to find what that hypotenuse is, because a coordinate point is always going to give you the opposite and adjacent side. That's why the unit circle is so nice in giving us always cosine comma sine, our adjacent side comma our opposite side. So hopefully that helps. You'll also have questions that are like question number 12 here. Suppose that tangent of theta is equal to 24/7 and cosine of theta is less than 0. I'll go ahead and say right now, the only purpose of this is, again, to talk about what quadrant you're in. And all your quadrant relationships do is tell you which ones are positive and which ones are negative. Before you do any math with this idea in number 12, that tangent of theta is 24/7, please note that that's a positive number. You're in a situation here where tangent is positive, but if your cosine value is less than 0, that means cosine is negative. And if that's the case, well, you can't be in quadrant 1 if things are negative. And that begs the question, where's the only other place where tangent is positive? Pause for effect. Sure. You're in quadrant 3. Your values of tangent and cotangent will be positive. Cotangent, you don't even have to calculate, though. See how I just highlighted tangent? Cotangent is the reciprocal of that. You start this question not just knowing one trig function, you know 2 of them. Then you have to go and find the others by, again, drawing a right triangle. You're in the 3rd quadrant, so draw yourself a little bit of axes if you really want to. Put that triangle down here. Your angle is always touching the origin. And if you have tangent is 24/7, I have definitely not drawn this to scale because there's my opposite over adjacent. And again, Pythagorean theorem or Pythagorean triple to find what your hypotenuse is, fill in the rest. You already know that cosine is supposed to be less than 0. I immediately go and say it's negative. But cosine is also adjacent over hypotenuse, and so my answer is -7/25. For these questions, and I again will pause for effect for just a second before I go to my notes from this and throw them up here, that's all you're asked to do, is to fill in the rest of those based on creating yourself a right triangle. You may get to the point where you don't even need the right triangle if it is a Pythagorean triple. It makes it a lot easier. Even in some cases where you can just find out that the hypotenuse is radical 10, you don't necessarily need to draw that right triangle in a problem like number 11. What you will have to do is, as always, make sure your answers are fully simplified and that any denominators are rationalized. So can't leave it as 1 over radical 10, or sorry, -1 over radical 10 for sine of theta in number 11. You would have to multiply top and bottom by radical 10. So again, I am going to give you problems like this. You'll see them in Delta Math in just a moment. But these are 2 of the different types of questions that you're going to see. Let's talk about the 3rd, and that comes from the exact value of trig functions packet that you were working on, where I said, hey, your homework is to do all these questions, and here I have the 9 examples from the 2nd page. You're probably pausing right now and double checking your answers. That's cool by me. I actually want to go to the page after this. You've got 6 more examples down here. Try them if you'd like. Double check them on your unit circle or use the internet, whatever you have to do. But of course, you're not going to have the internet with you when you're asked about these things on a, let's say, short assessment on Thursday and Friday. Pause for effect once again. Understanding of the unit circle will make it much easier to evaluate certain functions, especially those that are multiples of 90 degrees or pi over 2. 90 degrees or pi over 2 on the unit circle, we are talking about what are called if you ever see this word, quadrantal angles. You see the word quadrant in there, but actually they're the ones that don't live in quadrants. They're your 0, your 90, your 180, your 270, your, 360. Your 0, pi over 2, pi, 3 pi over 2, that sort of thing. If you can figure out, though, where those points are, that makes the job a lot easier. You don't have to worry about memorizing radical 3 over 2 or radical 2 over 2 or 1/2. You just have to say 180 degrees, that's on the left side of my unit circle. That's the point -1, 0. And if I'm asked then to evaluate any of my trig functions, I'm doing the same thing I would do on the unit circle. I'd say sine is equal to y, cosine is equal to x, tangent is equal to, etc., etc. It's just a lot easier when those numbers are just 0s and 1s. Oh, look, my x value is -1, my y value is 0, sine is y, so sine of 180 is equal to 0. Cool, that's it, I'm done. That's all I'd have to do. And again, The hardest part of this would be just making sure you know where you are on the unit circle. 3 pi over 2 is at the bottom. Here's x, cosine is 0. Tangent of 2 pi. 2 pi is 1 entire unit circle. You're back to that very first point, the same as 0 degrees. So, spoiler alert, here's 0 degrees down here. And all we'd have to say then is, okay, great. Tangent of theta is equal to y over x. Tangent of 2 pi is equal to 0 over 1. Tangent of 2 pi is equal to 0. You're going to find that there are a lot of different values here where we're going to get answers that are, well, zeros and ones. And that's fine. That's perfectly acceptable. That's perfectly reasonable. I'll leave that there. Why not? It's not taking up too much space. Obviously, for your reciprocal functions, keep in mind that you're going to have to flip some stuff upside down. Here's the only point that I don't think I've written here of the quadrantal angles, 0, 1. But cosecant, oh no, says I have to take my y value and reciprocate it. The reciprocal of 1 is still 1. So cosecant of pi over 2 is the same as sine of pi over 2. It's 1. Now, the one that I want to talk about the most is y. Cotangent of pi. Well, pi is 180 degrees, so let's go ahead and say that's on the left side of my unit circle at -1, 0. And I could find what tangent of this angle is and then reciprocate it, or just remember if tangent is equal to y over x, then the reciprocal of that, cotangent, says I'm going to do x over y, or -1 over 0. And dividing by 0 is not a pleasant idea. You try to do it in the calculator, and the calculator says, I'm sorry, I can't do that. And so what we are going to find for our quadrantal angles, only the ones that are multiples of 90 degrees, and yes, that includes 0, which is a multiple of 90. It's 90 times 0. We will get to places where we will say that we don't have an actual solution to our problem. We will get to a place where we can say that value is not a number that exists. It is undefined. It does not have an answer because we cannot divide by 0. We'll talk a lot about dividing by 0 later this year. Trust me, you'll love it. But for now, please note that yes, we now can see certain answers when we do this work that says, oh, you know what? Yeah, we can have things that just don't work out. There are going to be places on the unit circle that we don't, in fact, get those things. And let me go ahead and, again, throw that on the screen right now. You can absolutely have a case where you get something that is undefined. We'll only see it in one of those 4 corners, or I should say the up, down, left, right of the unit circle. But please be on the lookout for them because you will be asked for those, not just on assessments for me, but also on the assignment I'm going to leave for you now. In terms of anything else I'd ask of you, there's some more questions on this page of the exact values packet. Those questions look familiar. That's here's the point that our terminal ray of the angle is passing through. Find your 6 trig functions, or in the case of number 3, just find sine, cosine, and tangent. Back page is more of those examples of here's one trig function, its value, and here's something you can tell me about one of the other trig functions, whether it is positive or negative. All that positive or negative is going to do for you is tell you which quadrant you're in. But still, find the exact values of all other trig functions. In some cases, it will still just be a Pythagorean triple. In some cases, you will have to do Pythagorean theorem. Please just remember, and let's just go ahead and remind ourselves of this very quickly. Oh no, secant of theta is equal to 2. That's not a fraction, so I can't do my opposite adjacent hypotenuse thing, unless, of course, I recognize that any whole number is a fraction over 1. And so it does turn out that you do know 2 side lengths. One of them in your circle will simply be the number 1. Keep that in mind, and do try to always simplify all of your radicals as well as rationalize all of your denominators. Again, I'm leaving basically the last page and a half of this packet as additional practice for you, as well as parts N through S. I'll post the notes for these in Google Classroom, probably if you're watching this video, about right when I've said this, so about 15 minutes into class or so. That said, you're going to have a Delta Math assignment that is a little bit longer than the one that you've had before. This one's going to be a total of 40 questions that I asked you to do. Apparently, I didn't give you guys enough questions last time. Many of you flew through that. I'm very happy to see that. If you struggled a little bit, that doesn't mean anything. We're still talking about the very first week, but a lot of these problems are repetitive. That's why I wanted to give you many options of it. Again, I am looking at a short assessment by the end of this week on this sort of thing. Of course, it would not be at the beginning of class on Thursday or Friday. It would be after we've had some time to talk about these kinds of questions, iron out any sort of difficulties that we have before we move forward. So I want to show you at least one example from all 5 of these sections, just so you know what kinds of questions you will be asked. There's nothing that's going to be new for you. So when you open Delta Math, again, this should be posted in Classroom right about now. Signs of all 6 trig functions, here is that exact kind of thing that we were just doing. When each of these functions is positive or negative, what quadrant are you going to be in? Well, if 2 different types of functions, and when I say different types, I mean sine, cosine, tangent, and then their reciprocals would match with them. So this says cosecant and tangent, which is basically the same thing as saying sine is greater than 0 and tangent is greater than 0. That only happens when everything is positive. That only happens in quadrant 1. And then you'll continue over and over again. You'll get some where you'll get the negative signs. Make sure you're understanding what that means. Again, if you get a question wrong, what happens? It explains to you why it is you were wrong. So I believe it also explains to you why you're right if you get them right. So please keep that in mind. Again, your penalty system here, not like IXL, you're not dragged back 15 questions if you get one wrong. For every 2 questions you get wrong per section, you're going to have to get another question right. So if I was to go to the next problem, randomly click on quadrant 1, which I know can't be true because one of my trig functions is negative, my score is now a 0. I do have to get 10 questions right now, again, even though I'd already got one right to get to my full score. Easy enough. You guys don't need too much from that. The next 2 sections, exact value of trig functions, are like the ones that you saw in your homework. And oh god, that one's just very easy because it's 0 degrees. If you're comfortable with the unit circle, and again, that idea of, oh, it's a radius of 1, I'm going up, down, left, right by a number 1, and my x value, 1, 0, says this. You get 10 questions, or at least you have to get 10 questions right, where these are in degrees, and you'll have to get 10 questions right where these are in radians. Yes, it does allow you to say undefined for the cases where that might in fact be the case. It does allow you, of course, to put in radicals, which you will need to do in some of these scenarios, I'm sure. Can I just erase that? Nope. So here's my radical 2 over 2. Maybe don't do what I did because that, okay, there we go. Hit the fraction, radical 2 over 2, do your thing. Get your answer. You can hit the left, right buttons as well to move this. I'm on the iPad right now. If you're on the computer, maybe it's easier to just click, but either way, it'll explain to you how to get there. You can see it's going to go through, hey, here's your first quadrant angles if you need those. But either way, great. The remaining 2 sections are the ones that you just saw in this video as well. Find trig ratio given another. Here is the ratio. You have to say, oh, that angle is in quadrant 4. I'm not even saying now, based on what is positive, what is negative, this angle's in quadrant 4, which means this asks you for the exact value of cosine. Cosine's positive in quadrant 4, your answer had better be something that's positive. Write your answer in simplest radical form using a rational denominator. Yes, you would have to do Pythagorean theorem with this. I believe your other side length becomes a 9. And so, oh goodness, can I get this right? Off the top of my head, I sure hope so. When I go to rationalize this thing, I will get something that looks marginally correct. So again, it's going to tell you to do Pythagorean theorem. It's going to tell you to find that remaining side length. And then it's going to tell you to do SOHCAHTOA again. Hopefully not too bad. Again, the last section, find trig ratio from a point. Literally, there's a 7 and a 24 again. We had one that was that. It's a Pythagorean triple with 7, 24, 25. So hopefully, again, not so bad. Find the exact value of cotangent. If you're given a point, you're given the adjacent side, comma, the opposite side. The answer to this problem is -7 over 24. You won't even have to do Pythagorean theorem if you're asked for cotangent or tangent. When you are asked for something like sine or cosine, well, that's going to be a little bit different. And again, it can give you examples. You can see how it all goes. In some cases, you'll have to find the hypotenuse. In other cases, you won't. Please just make sure you're rationalizing denominators and simplify any radicals. If you see the square root of 50, make sure you're writing that as 5 radical 2. So again, total of 40 questions. Hopefully it's not the worst thing you've ever seen in the past. Have an extra sheet of paper handy or have an extra window in the iPad where you can do scratch work so that it's easier for you to compare and get those things done. Again, my sincere apologies that I'm not there to work through this with you so you can see how all of these things go, but you can expect to see all of my notes in all of their ridiculously color-coded goodness show up in Google Classroom momentarily. I will include all the rest of the answers for the exact values packet as well. I would encourage you, of course, to do questions 2 through, I believe it's 8, on your own. Try them out before you check my answer keys, just to, again, to get that practice, because you will have a question like one of those last 2 types of it's going through a certain point, or here's a ratio in a quadrant, you tell me what the other 5 functions are. So again, if you have any questions at any time for all of this, if you're going through the Delta Math section and anything jumps out at you as being particularly challenging, send me an email. I might not be able to respond right away, but hopefully within at least the day, if not the hour, if not the period, I can get back to you and give you at least a little bit of a boost as to how it is you're supposed to get that. Your due date is not going to be September 23rd. This is just my sample thing. It's going to be posted in Classroom. It will be very clear. And yes, the next time that you see me in front of the classroom and actually in the room with you, we can go over these kinds of problems if there are any lingering questions before we would ever take our short assessment. So thank you all. I apologize again I can't be there. Hopefully I will see you by the end of this week.